So let us start today. So can you hear me, everyone?
Yes, sir.
Okay. So also can you see the screen now? What I am sharing? Everyone can see?
Yes, sir.
Okay. 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 So see, we were discussing about settlement analysis of Salo Foundation, and in that we have started discussion about consolidation settlement, and up to consolidation settlement, up to the point how to calculate the settlement because of consolidation, that we have discussed. Now remaining part of the consolidation, that is how much time will be required for consolidation, that is pending. So we will be taking it up at a later date, but before that we will try to discuss about the codal provision or Indian Standard Code. What does Indian Standard Code says about settlement analysis of Salo Foundation, that we'll discuss. And if you see your syllabus, then in the syllabus, if you observe that there is a module 5 given, and in that module 5 the settlement, this is basically settlement analysis of Salo Foundation. So allowable bearing pressure and settlement analysis as per IS 8009, immediate and consolidation settlements, rigidity and depth factor corrections, settlement value as per IS 1904 recommendations. So if you see the handout I have sent out today, in that, in the presentation, all these things are discussed, as well as I have sent you along with the presentation this IS 8009 code and IS 1904 code also. So what you can do, you can study, you can refer those two codes, as well as what you can do, you can directly download from the internet those two codes. I don't think there is any recent version of this code. So whatever the versions I have sent you, those are the latest version of the code. So to start with the discussion on settlement analysis of Salo Foundation, let's see what is actually, see these things we have discussed already. So you know that settlement of any Salo Foundation consists of three things, that is three types of settlements. Basically we have seen that at the very initial stages of our discussion on consolidation settlement, where we have understood about what is immediate settlement, what is primary consolidation, and what is secondary consolidation. So basically settlement of any Salo Foundation will consist of three things. That is, first one is immediate settlement, that occurs immediately after the construction, and where it will be occurring, when the soil is granular in nature. That means in a purely non-cohesive soil, you may expect a good amount of immediate settlement occurring. Okay. So where the computation is basically based on the immediate settlement, then the soil needs to be granular in nature. Okay. So in that way, if you think that immediate settlement, it's mostly the property, or mostly it will occur in case of non cohesive soil. However, if you think that only in the non cohesive soil it will occur, it's not true. It may occur also in case of the cohesive soil also. Okay. So in case of cohesive soil, if it occurs, if in case of cohesive soil if it occurs, then you need to know how to calculate the value of the immediate settlement for cohesive soil. So both these things we will discuss in today's discussion, and what does the Indian Standard Code is saying related to the immediate settlement calculation, what is the formulation, and what are the things you need to know for immediate settlement calculation, that we will discuss today. Second is primary consolidation, and you see that primary consolidation we have discussed in detail. Totally we have discussed about primary consolidation of normally consolidated clay as well as over consolidated clay. So you now understand what is primary consolidation. Basically, that is the gradual dissipation of the pore water pressure induced by external loading, right? So when the pore water pressure is basically dissipated in a clayey soil, or in case of inorganic clay soil, when the dissipation of pore water pressure happens because of the external loading coming onto the clay from the foundation, from the load of the superstructure to the foundation and ultimately to the soil, and when this dissipation of pore water pressure is happening, then at that point in time what will happen, there will be expulsion of water from the soil mass, and because of the expulsion of the water from the soil mass, the there will be change in the volume of the soil mass. Okay, so that is basically your primary consolidation. Okay, and the third one, as you know, that is not very important from our civil engineering perspective, because it will take lot of more time, and the amount of settlement because of the secondary consolidation will not be much, and it will be more important for in organic kind of soil. So when there is an rearrangement of particles, when there is a rearrangement of particles, then you can expect some kind of secondary consolidation happening to the soil structure. From the perspective of our civil engineering, we are not much concerned about this secondary consolidation. I have already discussed this part earlier also. So the total settlement, if you want to find out for any soil mass, in that case you see the settlement will be given by the immediate settlement, primary consolidation settlement, and secondary consolidation. If you sum it up, then you will get total settlement. So if we just neglect the secondary consolidation part, then you see you need to know at least the immediate settlement and primary consolidation settlement. Okay, so the primary consolidation settlement, how to calculate that mathematics behind it and how to find out it, we have discussed earlier, as well as we will now discuss the same thing again from the codal perspective. That means what does our Indian Standard Code IS 8009 is saying about primary consolidation, that also we will discuss. Okay, so for any of the above mentioned settlement calculation, as you know that for any of this above mentioned calculation, if you want to find out immediate settlement, primary consolidation, secondary consolidation, you know what you require. You need to know the vertical stress increase in the soil mass. That means the delta P or delta sigma, as we have discussed during our primary consolidation case, right? So you need to know how much is the incremental stress increase. That means from the superstructure, when the load is getting transmitted through the column to the foundation and ultimately from the foundation to the soil mass, because of that load increase, load coming from the superstructure, how much is the increase in stress, or the vertical how much is the vertical stress increase in the soil mass, that you need to find out. Unless and until you find out that delta P or delta sigma value, you will not be able to find out how much will be the settlement. And how do you calculate that vertical stress increase? If you remember, while discussing about consolidation settlement, I have shown you, we have discussed a problem also where we have seen that how to calculate the vertical stress increase using Boussinesq equation. So there are two equations primarily you can use for calculating the vertical stress increase in the soil. One is the Boussinesq equation and other one is the Westergaard equation. So both the equations we have discussed, and using Boussinesq equation we have seen how to find out the vertical stress increase in the soil. Other than the Boussinesq and Westergaard stress equation, if you remember, while discussing about the problems of primary consolidation, we have seen that by approximately making the stress distribution, considering it as a trapezoidal stress distribution, that means from the base of the footing the load is getting distributed in a trapezoidal fashion to the middle of the clay layer. Considering that, we can also find out the incremental vertical incremental stress. Okay, so these are the three methods through which you should be able to find out the vertical stress increase in the soil mass. Now next is, you see, in case of Indian Standard Code, in case of Indian Standard Code 8009, you will see that basically the settlement calculation, for the settlement calculation purpose, what does Indian Standard Code has done? 8009 1976, part 1 1976, which has been reaffirmed in 1998. That means whatever is the considerations of 1976, those considerations are being kept as it is, and it has been reaffirmed in 1998, and that is the code I have sent you also. So in that code, if you observe, if you refer that code, then you will see in the clause number 4.2.2 at page 9, you will observe that the total profile of the soil, that means the different types of soil profiles are being classified. Okay, and those classifications are basically of 6 types. So what Indian Standard Code has done, 8009 has classified the soil profile under 6 categories. Okay, and obviously the settlement calculation, for the settlement calculation purpose, these soil profiles to be used. Okay, and for calculation purpose, you need to model the profiles in a simplified manner. Okay, so that is what the Indian Standard Code has done. For settlement calculation purposes, soil profiles may be simplified into one or more layers depending upon the extent of uniformity. This is very important. So if the soil profile is uniform, then you should be able to very easily model the soil. Otherwise, if it is non-uniform, then the challenge comes. Okay, and considering the uniformity of the soil profile, Indian Standard Code has given some basic profiling of soil, and based on that, mostly you can classify the soil profile under 6 categories. Okay, the first one, if you see, a deposit on cohesionless soil resting on rock. This is the first kind of profile Indian Standard Code is saying. So a deposit of cohesionless soil. So basically, what is cohesionless soil? Cohesionless soil means granular soil or sandy soil. The soil is completely resting on rock. Okay, so basically a sandy soil profile is resting on a rocky stratum. So if a deposit of cohesionless soil resting on rock, and if that soil is kind of loose in nature, then you see in such kind of soil you may expect only immediate settlement, because a deposit of cohesionless soil resting on rock means it is granular soil, it is cohesionless soil. So only settlement you can be expecting in such kind of soil is basically your what is called immediate settlement. In case of granular soil, cohesionless soil, you are not going to expect any kind of consolidation settlement. Okay, now the next two profiles are very important. We have solved problems for our consolidation settlement, if you remember, using these kind of profiles of clay. See, a thin clay layer sandwiched between cohesionless soil layers. So that means what? A thin clay layer. A clay layer is in between. I will show you the diagram just 2 minutes after discussing this theoretically. See, a clay layer, a very thin clay layer, let's say very thin clay layer is in between the two sand layers. That means on top of the clay layer there is a sand layer, and on bottom of the clay layer also there is a sand layer. Or there may be a case that at the top of the clay layer there is a sand layer, and at the bottom of the clay layer there is rock. So both the cases it can happen. Okay, so a thin clay layer sandwiched between cohesionless soil layers. So this is very important, sandwiched. That means on top there is some layer, on bottom there is some layer, and in between the clay layer is existing. And on top of the clay layer there may be cohesionless soil, on bottom of the clay layer there may be cohesionless soil, as well as there may be a case where at the top of the soil there may be cohesionless soil. However, at the bottom of the soil, bottom of the clay layer, there may be rock. Okay. So this kind of soil, if you think in such kind of soil where a clay layer is sandwiched, in that case you may expect amount of consolidation settlement occurring in the clay layer, and we have solved problems while discussing about consolidation of soil, if you remember. Okay. So such kind of soil, if you see, there may be one-way drainage, there may be two-way drainage. That means if there are cohesionless soil layers at top and bottom, so what will happen? The water whatever is being expelled out from the clay layer may be able to percolate to the upper layer of the cohesionless soil as well as to the down layer of the cohesionless soil. So there may be two-way drainage, or it may be there may be a case where the soil layer is sandwiched between the between two layers. However, on top there may be cohesionless soil, at bottom there may be rocky layer. In that case, what will happen? Only in one way the soil will be able to expel out. Okay, so water will be able to move out only in one direction. Through the rocky stratum, water will not be able to percolate, so there is no chance of soil getting percolated from in that downward direction. If you go to the third profile, okay, if you go to the third profile, you see third and fourth profile looks to be same, but there is a difference. I will explain it through the diagram. See, a thin clay layer and a thick clay layer. So 3 and 4, if you see, this one is the third one, a thin clay layer extending up to ground surface and resting on cohesionless soil or rock. So this is very important, you see. A thin clay layer, a clay layer is there. See, in this case it is not sandwiched between two layers, rather a clay layer which is thin enough, and it is a layer which is extending up to ground surface. That means the clay layer is starting from the ground surface. It is not below the ground surface. It is starting from the ground surface. So clay is starting from the ground surface, and it is extending up to a layer, where it is resting on cohesionless soil or rock. If you see the fourth one also, it looks to be same. Only there is a change in the word. You see a thin and thick. So a thick clay layer resting on cohesionless soil or rock. What is the difference then? See, the difference is here the thickness of the clay layer. So both the cases, in both this third and fourth profile, if you see, the clay layer is starting just below the ground level. However, what is the difference? Difference is, in case of the thin clay layer, the layer thickness, the clay layer thickness will be lesser than the width of the footing. So you see, if you remember shallow foundation, where we have discussed about the effect of water table on the footing, if you remember, the influence zone of the footing is extending up to a depth B, that is the breadth of the footing, below the bottom of the foundation. Okay, so from the bottom of the foundation up to a depth B, the influence zone remains, and that's what is coming from Terzaghi's bearing capacity equation. Okay, so the wedge shaped zone, the triangular wedge shaped zone, if you remember, the from the base of the footing up to the vertex of that triangle, you will have a depth of B. Okay. Now, if your clay layer thickness, is lesser than that B, that means if your clay layer thickness is lesser than the depth of the footing below the depth of the soil layer below the footing level, which is less than B, in that case it will be considered as thin clay layer. Just opposite will be happening in case of a thick clay layer. So in case of thick clay layer, what will happen? The cohesionless soil layer or the rocky stratum will come into picture beyond the thickness of the clay layer, which is greater than B below the bottom of the footing, where B is the width of the footing. And then the fourth and fifth one is a deposit of regular soil layer. So deposit of regular soil layer means one after one the regularly soil is layering. That means one layer of clay, let's say, then one layer of soil, one layer of sand, then again say one layer of clay, then again say one layer of sand. Or it may happen that first there is a layer of clay with some other property, then the next layer there is sand with some different property. After that you get another one clay layer which is having different property than the clay at the previous layer. So if you remember, in shallow foundation, while calculating about your calculating the bearing capacity, if you remember, we have taken weighted average, right? Weighted average consideration, that for different kinds of clay and sand layers layering up, or in case of a mixed kind of layer which will be considered as a C5 soil, if you remember, we have calculated the weighted average of cohesion and weighted average of phi, and from that we are calculating the bearing capacity. Exactly the same way we should be able to calculate the settlement property of soil also in case of a regular soil layer deposit. However, you may also expect a erratic kind of soil deposit. Erratic kind of soil deposit means it is very difficult to handle, and in case of erratic kind of soil deposit, you may expect one soil layer here, one soil layer at other place. Means at same soil, at the same depth, you may expect some portion of the soil is sandy, some portion of the soil is clay, okay, some portion of the soil is mixed mode of sand and clay. So this kind of soil structure is very difficult to address, okay, and in many cases what is being done, if a very erratic soil structure is found below the ground level, the solution remains at excavation of the soil layer. You just excavate the soil layer, you just throw out the soil and fill it up with some fill material of uniform property, and then construct the foundation, okay. Now you see what diagrammatically this 8009 is saying, okay. So you see these are the 6, 1, 2, 3, 4, 5, and then there is a sixth one here. So you see the first one, if you see the first one, what have I said? The first one is the profile number 1. So that is, you see, deposit of cohesionless soil resting on rock. So this is a cohesionless soil layer, you see, this is cohesionless soil and it is resting on rock. So this bottom layer is rocky stratum, and on top of this rock there is cohesionless soil, and this cohesionless soil is extending up to the ground level. So the thickness of the clay layer is HT in this case, and this HT can extend up to the clay layer, up to the rocky layer, okay. So resting on rock, and in such case, you see, as it is the granular soil, it is a cohesionless soil, you may only expect immediate settlement in such case of soil. On the other hand, if you notice the case number 2, that is the profile number 2, you see it's figure number 2. In profile 2, you see what is happening. thin clay layer. So you see this layer is the thin clay layer. This is the thin clay layer. In between this white portion, if you observe, this is actually your thin clay layer. Okay, and you see this thin clay layer is just remaining sandwiched between two layers. So see, sorry. So two clay layers. You see, this is your thin clay layer, and you see this is sandwiched between this layer. This is a cohesionless layer, and between this layer, this is also a cohesionless layer. Okay, so this is kind of the soil profile you may expect, where huge amount of consolidation settlement can come, because you see the and consolidation settlement will be happening fast in this kind of soil layer. Why? Because you see, if cohesionless layer at top of this clay layer and bottom of this clay layer, then you see it is very easily getting two-way drainage path. Drainage path means water will be able to move out from this clay layer to the upper layer, because you know the granular soil is highly permeable, as well as to the bottom layer it will be also very easily percolating. And in that way, what will happen, the consolidation settlement, in case of consolidation settlement, this clay will find out a two-way drainage path. So one way is upper way, upper side, and the other way is in the downward side. So two-way drainage path it will be getting, and from this two-way drainage path it will be very easily consolidating. On the other hand, there may be case also where you see this clay layer may be sandwiched between, at the top there may be a cohesionless soil layer, and at the bottom, instead of this cohesionless soil layer, there may be a rocky stratum. So if immediately after that there is a rocky stratum, then you see what will happen. Through the rocky stratum, the water will not be able to percolate, because see, at this level, instead of this layer, if this instead of this layer being a cohesionless soil layer, if it becomes a rocky stratum, then what will happen? The water will not be able to percolate in the downward direction. So you see, this water, whatever is there inside this clay layer, that will be able to find out only a single way or single path in the upward direction. So this kind of drainage will be termed as one-way drainage. Okay, so this one-way drainage and two-way drainage will be important when you will be understanding about the calculation of time required to complete settlement. This is very important. Okay, time required to calculate the time required to complete consolidation settlement. Okay, now you see this figure 3 and figure 4, you see this is profile third profile and fourth profile. So third profile, you see, as I have said, see both are clay. So see, in this case, this clay layer instead of this figure 2, you see, in case of figure 2, this clay layer is getting sandwiched between these two layers, and this clay layer is not reaching up to this ground level. Instead, you see in this figure 3 as well as in figure 4, if you observe, this clay layer is reaching up to the ground level. That means the clay layer is starting from the ground level and it is going up to a layer where the rocky stratum is present. So this is the rocky stratum. Up to this clay layer is extending. In this profile 4 also, if you see, the clay layer is extending up to a rocky stratum. What is the difference? Only difference, you see, the breadth of the footing is in this case B, the breadth of the footing in this case is B. You see, in this figure number 3, or in case of profile number 3, where we are saying a thin clay layer. So thin clay layer means what? The B, the breadth of the footing will be more than the depth of the clay stratum. So depth of the clay stratum, which is getting extended up to this rocky stratum. That means what is happening? you see in thin clay layer what is happening. See the influence zone, which will be a triangular shaped zone, something like this. So this B will be extending beyond this rocky layer. So when this B will be extending beyond this rocky layer, that means when this B, that is the breadth of the footing, is greater than the thickness of the clay layer, then we will be considering it as a thin clay layer. On the other hand, if B is less than this thickness of the clay layer, that means breadth of the footing is less than the thickness of the clay layer, then this will be considered as a thicker clay layer. Now you see this 2, 3, 4, these are very important case to understand, because you see in whatever consolidation settlement we have understood, in that case, if you remember, we were considering the clay layer is being sandwiched between two layers or one layer, right? However, you see in this case, you see drainage path is in this direction and in this direction. So the one dimensional consolidation theory as given by Terzaghi, that means the clay layer will be getting compressed in the vertical direction. So you can just take the vertical stress increase, and using the vertical stress increase you can just calculate the vertical settlement of the clay layer. So in this case number 2 or the profile number 2, whatever one dimensional consolidation theory we have understood, that is very easily, that can be very easily applied. However, you see in case of profile 3 or profile 4, that means a thin clay layer or thick clay layer which is not sandwiched, which is just located between which is just located from the ground level to a rocky stratum. Sorry, in such case, you see the clay layer will not be able to find out a proper drainage path, okay, in the vertical direction, either in the upward direction or in the downward direction. So in such case, the water may be trying to escape in various directions, not in only in the vertical direction. So it may be trying to escape in the horizontal direction, it may be trying to escape in the diagonal direction, okay. And in such cases, it will be very difficult to apply the theory of one dimensional consolidation, okay. So if you cannot apply one dimensional consolidation theory, then considering that complexity, the analysis of this profile of clays as given in profile number 3 and profile number 4, it will be very difficult, okay. So you may have to apply two-dimensional or three-dimensional consolidation theory, which you may be learning in your higher classes, or if you are doing your masters in soil mechanics or something like that. But mostly very important thing, you should understand one dimensional consolidation theory, whatever we have discussed till now. Now the profile number 5, if you see, this is deposit of several regular soil layer. That means 1, 2, 3, 4, 5, 6, there are various soil layers up to the nth layer, and at the bottom there is a rocky stratum. So you see regular soil layer means, suppose this soil layer is having some soil property C1 phi 1, then layer 2 may be having C2 phi 2, layer 3 may be having C3 phi 3, layer 4 may be having C4 phi 4. So if you find a regular kind of soil deposit and layering kind of soil deposit below the ground, then what you can do for analyzing such kind of soil, the settlement analysis of such kind of soil can be calculated, can be done using the calculation of average value or weighted average value of the total soil profile. That means you should be able to calculate the value of C and phi. So how do you calculate C? So if you remember, you can calculate C easily using C is equal to C1H1 plus C2H2 plus C3H3 C4H4 divided by H1 plus H2 plus H3 plus H4. So if you take the height of the soil layer, multiply it with the Poisson values, and then take a weighted average, and in case of phi values, if you can take the weighted average of tan phi, So tan phi 1, tan phi 2, tan phi 3. So that means H1 tan phi 1 plus H2 tan phi 2 plus H3 tan phi 3 divided by H1 plus H2 plus H3. Such way we should be able to calculate the value of average C and average phi, and considering that average C and average phi value in case of a deposit of regular soil layer, you should be able to calculate the uh, settlement value of foundation or settlement of soil. Now the last profile you see, if you see, it is the sixth profile is basically is your erratic soil deposit. Now you see how does the regular soil deposit and erratic soil deposit differ, you see, observe. So in see regular soil deposit, see the thickness is almost constant, you see, thickness of the soil layers is almost constant throughout. Whereas you see in case of erratic soil deposit, see this soil layer 1, it is present over here, it is present somewhere here, it is present somewhere here, it is present somewhere here. Then 2, in between this soil layer 1, there is some portion of the soil is having some other property, some portion of soil is having some other property with 3. So this kind of soil layer will be termed as erratic kind of soil deposit, and such kind of soil is very difficult to analyze for settlement purpose. And for that reason, as you will not be able to analyze for settlement purpose, so for constructing huge amount of a huge construction on top of such kind of erratic soil deposit will be always risky, because in such kind of soil deposit you can always expect differential kind of settlement. What is differential settlement? Differential settlement means suppose this layer number 1 is your sandy soil, and this 2 is your basically clayey soil. So what will happen? Suppose you are constructing a column over here and you are constructing a column over here. So let's say at same depth you are constructing. So your one footing will be on clay layer 2, and one footing will be on sandy layer 1. So what will happen? This sandy layer 1 will be going only immediate settlement, whereas if you see this soil will be going through consolidation settlement, because on top there is sandy layer, on bottom there is sandy layer, so there will be consolidation settlement. So immediate settlement will be happening to this. So at the initial stage the footing will be just settling immediately, whereas in this part the footing, whatever the footing you are constructing, this will be going through consolidation settlement, and in the years to come it will settle, and maybe this settlement may be more than this settlement. So what will happen? The footing, whatever you will be constructing over here, that may be going down much deeper than this footing. So there will be a tilt happening, and this kind of settlement is called differential settlement. And as soon as the tilt in the footing or the construction level will happen, you see there will be cracks getting generated inside the structure. So differential settlement is very difficult to address. So to avoid this kind of phenomenon, what you should do, if you find an erratic soil deposit below the ground level, the general practice being followed by civil engineer is to excavate the soil mass and throw the erratic soil deposit out from there, and then you fill it up with a uniform soil deposit, maybe sandy soil, or it may be a uniform kind of clay. Okay, then only you start constructing the structure. Okay, so till now if you have any doubt you can ask. Okay, now you see, if you go through IS 8009, see these two clauses I have just taken from IS 8009 only. See what is being said, whatever I have discussed till now, that is being summarized here. So what is said over here, you see in section 4.2.3, if you go to IS 8009, you will notice where there are both cohesionless and cohesive soil layers. That means in a soil mass where there is a cohesionless soil mass, cohesionless layer, as well as there is a cohesive soil layer. Unless the cohesive layer is thin, that means if the cohesive layer, that means the clay layer, if it is very thin, or the cohesive soil is stiff, that means the stiffness of the clay layer is high, or the cohesionless soil is very loose, that means on top of the clay layer, let's say there is a cohesionless layer and there the cohesionless soil is very loose, the settlement contribution by the cohesionless soil layer will be very small compared to that due to the cohesive soil layers. That means what is saying? Suppose there is a sandwiched clay layer between two cohesive soil layers, and if the thickness of the cohesive soil layer is very thin, okay, and the granular soil layers, that is the cohesive soil layers, is very loose, in such case only you will have to concentrate more on calculating the immediate settlement value of the cohesionless soil layers. If you find that the thickness of the sandwiched clay layer between two cohesionless soil layers is more, and if the cohesionless soil layer is not very loosely packed, or it is little bit tightly packed, or you can say the relative density of the cohesionless soil layer is high, in such case you may not calculate, or you may not consider the value of the immediate settlement for calculating the total settlement of putty. So primarily only you will have to concentrate on cohesionless soil, cohesive soil layer. In the exceptional cases cited above, okay, in the exceptional cases cited above, the settlement due to all the layers have to be estimated. What is the exceptional case? Exceptional case means, suppose you have a clay layer which is thick enough and it is sandwiched between two cohesive soil layers, or it is sandwiched between a cohesive soil layer at top and a rocky stratum at bottom. However, the cohesive soil layer, cohesionless soil layer is also very loosely packed. In such case, you should consider both the things. That means you must consider the immediate settlement of the cohesionless soil layer, as well as you should consider the consolidation or primary consolidation settlement of the primary consolidation settlement of the what is called clay layer. Okay, rock is incompressible, so there will not be any settlement for the rocky stratum. So the settlement for rocky stratum should be neglected. Okay, is it okay? Now the last point, see, in today's class we will discuss, that is section number 4.2.4. if you see, the method of computation. So the method of computation for cohesionless deposit. So you see, cohesionless deposit, if you see, cohesionless deposit is basically going through immediate settlement. It does not go through consolidation settlement or primary consolidation settlement or secondary consolidation settlement. So the method of computation for the settlement of cohesionless deposit differs from that of a cohesive deposit. Obviously it will differ, right? So immediate settlement calculation will differ from the cohesive deposit. The settlement of a thin clay layer shown in figure 2 is one dimensional. That is what I was telling you. See, the settlement of a thin clay layer shown in figure 2. What is figure 2? I was explaining it. So this is a thin clay layer which is sandwiched between two cohesionless soil layer either, or one cohesionless soil layer at top or a rocky stratum at the bottom. In such case, you see what the code is saying: the settlement of a thin clay layer shown in figure 2 is one dimensional. That means you can apply Terzaghi's one dimensional consolidation theory over here. Whereas in a thin clay layer, see the thin clay layer in case of figure 3 or a thick clay layer in case of figure 4, the settlement depends upon lateral deformation, as I have explained you, because this in case of figure 3 and figure 4, that means this thin clay layer and thick clay layer case, I was explaining you earlier that it will not find any path in the vertical direction either in the upward or downward direction for escaping the water or the pore water pressure. So the water needs to be escaped, and the water will be escaped either in the lateral direction or in the diagonal direction or whatever may be the direction. So it must go through the lateral deformation. So the different types of soil, so see, in that case you cannot apply one dimensional consolidation theory in case of your profile number 3 and profile number 4. So thus the different types of soil formation will require different methods of settlement calculation. In our next class, we will discuss about this point, that the method of computation of cohesionless deposits. So how to calculate the sorry, how to calculate the settlement for a cohesionless deposit, that we will be discussing in our next class. Okay, so we will stop here today, and let me take the attendance. So is it okay? If you have any doubt, you tell me. So you can ask me. Is it okay? सबको समझ में आया?
सर
बोलो।
अगर कहीं पे रॉक ही रह गया पहले तो सॉइल प्रोफाइल में,
रॉकी
रॉक वाला लेयर आ गया सर पहले, तो उसके बाद रहा कोहेशनलेस और कोहेशन वाला।
suppose you are constructing a foundation on a complete rocky soil, rocky layer, okay? So in that case, you see, you are not going to expect any settlement, because the code also it is very clearly said that rocky stratum will be incompressible stratum. If you see this part is saying that only. See, if you see this line, this is very clearly said that rock is incompressible compared to soil, and therefore the settlement of rock stratum is neglected. So if you are constructing a foundation on a purely rocky stratum, then you can expect that there will not be any settlement coming inside that soil mass, that rocky stratum. Is it okay? So let me take the attendance. So very few people are attending. Now Chhat is over, Diwali is over, everything is over, right? Utkarsh, you just give a message to everyone, okay? And maybe in the next week we are going to have, not maybe, we are going to have evaluation, first evaluation for CA, okay? So class assessment 1 will be taking in the next next week maybe. So you tell everyone to get prepared, because this time CA will be taking little bit seriously, and also maybe in 1 hour's time you will have to do complete your answer and then upload it, okay? So it will not be given like that and then after 1 day you will be submitting and all, okay? So obviously mentors will be updating you about these things, okay? And we'll decide on how to take the CA in the next week, okay? So Utkarsh, you please give a message to everyone that now they should come to the class and attend the class regularly, okay? Otherwise we have decided that we'll take a details of this next 10 days or 15 days classes, and then inform their parents also that the people are not attending classes. We'll take a record of that, okay? So let me take the attendance for today. We'll stop here. today's attendance is very less. It's not at all satisfactory. Should I clear it or? Okay. Okay. So thank you everyone. So next class we are having at 1:45, right?